Hey, welcome to your practice test. I hope you've done some revision. If you haven't, you better get back there and do some on this unit called number. Okay, so here we are. I want you to put your name on your paper there. Okay, so we write our name on the paper first of all. Might get a mark for that. No, I don't think so. Anyway, so what we're going to do with this video practice test is I'm going to scroll through the whole test. There's 42 marks. And you ought to pause the presentation and do the question. Do it on your own paper or on your own computer there. And what we're going to do is at the end, when you've finished, stop, check your work, and then I'm going to go back to the beginning and show you how each of the problems is done and how they're going to be marked. It's 42 marks, so you'll need about 1 minute per mark, about 42 to 45 minutes. Are you ready? There's your first question, question 1. List the 5 multiples of 8. Pause it, have a go. Coming down now, question 2. Okay, pause it, have a go. Question 3. I think there are 11 questions. Question 4. Question 5. Question 6. Question 7. Question 8. Question 9. Couple to go. Oh, some applications to the real world. And the last question, question 11, haven't got any marks on that. Oh, where are they? Down there, okay. 6 marks, but I'll just come back up here a bit. Oops, hang on, let's just go in between. Here we go, 6 marks for this one. All right, once you've had a go, stop, check your work, toggle back, but don't go forward because I'm going to go forward now and show you all the answers and how to mark it. Okay, so we're going to go back to the beginning of the test. Here we go. We're going to start now. So this is the 5 multiples of 8. Well, multiples are whole numbers times the number. 1's 8 is 8. 2 8's are 16. 3 8's are 24, 4 8's are 32, 5 8's are 40. So if we listed the multiples, they would be 8, 16, 24, 32 and 40. Okay, so it's only 2 marks for all of those, so it's -1 for each error. Okay, there's no half marks and stuff in maths marking anymore. Okay, so what you get out of 2, put your mark here, because I want you to add them up later on. Okay, come down now, let's have a look at numbers 18 and 30. Find the highest common factor between those two. Well, I don't know how you want to do that. Number tree, factor tree rather, or division, or just list the factors of 18. Either way, we'll do listing the factors first of all, maybe. So 18 is 1 by 18. So we'll list these out in a minute. 2 by 9, divide by 3. 3 by 6. 4, 5, 6. That's all, I think. So what have we got there? Now, listing the factors would be what? 1, 2, 3, 6, 9, 18. And what about 30? 1 by 30, 2 by 15, 3 by 10, no 4s, 5 by 6, 6 by 5, and then it repeats. Okay, so what have we got? 1, 2, 3, 5, 6, 10, 15, and 30. So the highest common factor is going to be what? Let's have a look here. 6, looking for the overlap. The best way of doing it is to break it down to primes and actually construct what the highest common factor is. But we'll do it this way, because the next question is about primes. Okay, so this is part A, and if we go to part B, the multiples, it's 1 by 18 is 18, 2 by 18 is 36, 3 by 18 is 54, 4 by 18 is 72, 5 by 18 is 90. Okay, what about 30? 30, 2 30s are 60, 3 30s are 90. Oh, we've got it. There's the lowest common multiple. So we'll write our answers now. HCF is 60, lowest common multiple, LCM is 90. Now, I think this one over here with all the factors is a bit harder, so there's 1 mark there, 1 mark there, and 1 mark there, and over here 1 mark for each of those, and well, include the answer in that. So that's out of 5 now. So mark your work. You can see how you should put setting out, and if you just got the answers, that's okay for this problem, but by and large we need a solution, not just an answer. Must show the working for each of them. Okay, let's move on now to question 3. Use a factor T to write 54 as a product of prime factors in index form. Well, I'm going to do it 2 ways, and you can do this, of course, this method, for finding the highest common factor in the LCM. And I like that method, but for that, I think it's better. You're actually constructing and showing why the number is the highest common factor or lowest common multiple. You're actually indicating the maths, the common prime factors of the 2 numbers. All right, let's do it in a factor tree, but you may use division, so I'll do it that way in a minute as well. 54, now you've got to think of 2 numbers times to give 54, 9 and 6. Then 2 numbers multiplied to give 9, 3 and 3. Won't go any further because they are prime. Now 6 is 2 by 3. Won't go any further because they are prime. So 54 in order is 2 times, now we've got a 3, a 3 and a 3. So that's 3 cubed. Remember the power or index form there, or exponent form. What about doing it the other way by division? You start with the smallest prime, divide it. Now, if that doesn't go, you go to the next prime, because 2 doesn't go into 27. Divide by 3, and then divide by 3 again. Okay, so divide by 3 is 9. Oh, what's that? And divide by 3 again is 3, and keep going until you get 1. That's a division method. So 54 then, you just go down here and read it, 2 by 3 by 3 by 3. So same way there. Okay, so there's 4 marks there. Basically showing some working of factor tree, 1, 2, 3, and 1 for the answer. So if you just written the answer, we'll give you 4 marks this time. But remember what we want in maths, not just the answer, but a solution showing you how the answer was obtained. And there's generally part marks for that. So let's set it out well. Okay, let's look at question 4. Between which 2 consecutive, now when you read maths, it's not a bad idea to underline some words that you might not be sure of. Consecutive means one after the other or next to each other. Okay, integers next to each other. Does root 75 lie? Well, let's try and do it without a calculator. The root of 75. Now let's take a square number around there. What's a square number around 75? I don't know. 6 sixes are 36. Start there. I actually do know, but I'm not telling. No, let's try 8 eighths. 64. So 8 eighths is 64. What's 9 nines are 81. Okay, so that means what we've got there is 64 is too small, 81's too large, 75 is somewhere in the middle. But we know the root of 64 now, because we've seen that 8 eighths of 64 is 8, and the root of 81 is 9. So there's our answer. Root 75 is somewhere in there. So the answer is between the consecutive integers 8 and 9. Okay. That's the best way of doing it. You could do it on the calculator, root 75, and find what decimal it is. It's 8 point something or other. Okay, so there's 2 marks for that. So between 8 and 9, just give you 2 marks for those 2 numbers. All right, come down. Let's have a look now at, I reckon this is a Bedmass problem. Okay, so let's look at it carefully. So I'll write Bedmass down so I can use it. Now, we always work from left to right and then check Bedmass as we go. So we're starting at 2 times 5. Yes, that's got to be done, multiplication, before that addition. So it's 10 plus 5, and so the answer to that one is 15. So start with here now, start at the left, scan across the problem. Brackets comes first. That's the B up there. So we've got to go 2 times 10, and then we've just got the one operation, so that's 20. Checking this one, reading across, multiplication, there it is again, before subtraction. So it's 10 take 5, which is 5. Okay, coming across, scanning from here, B, Bedmass, brackets first. So let's go and do that, and then the multiplication, 2 noughts and 0. So we've got 4 answers there, so it's just 1 mark each. Okay, 1, 2, 3, 4. Put your mark down here so you can add them up later on. All right, let's go down to question 6. List the square numbers between 700 and 800. Let's imagine we're doing it without a calculator, of course. So 700 is a fairly big number. 10 by 10, you might have to use a calculator, is 100. 20 by 20 is 400. So we're too low. Let's try 30 by 30 is 900. We're looking at square numbers, so I'm squaring various numbers here. So it's somewhere here between 20 and 30. So what you're going to have to do is use the calculator, I think, and try 21 squared and so on. Yes, you won't be able to do that in your head, or long multiplication take too long. So if you keep going now here, 21 squared, 22 squared, and you can see it's got to be up near the 30 squared. So the answer is 27 squared and 28 squared. 29 squared is too big, okay, and the others are too small. So you've got to use calculator for that. All right, so, I've given 4 marks. I'll give you for two for each. I think that's a bit lavish. Okay, 2 for each there. All right, come on down, let's have a look. I hope you're getting some marks here. Simplifying this, this looks like another Bedmass problem. Another Bedmass problem. Okay, so starting, read the problem across there. Here we have the operations there that'll come first. Exponents and multiplication. So let's do the exponents first. 36 plus 3 times 5. Now we'll do the multiplication because the addition is down here. The multiplication is first. So it's plus 15, and that's going to come to 51. Right, let's go across to this one, reading across, looking. Here we have division as the first one. There it is in there. Division and then the rest. So let's do that first. 12, take 8 divided by 2 is 4 plus 1. Now these can be done in any order. Let's work left to right, therefore. Doesn't matter, the addition and subtraction down the end. 12 take 4 is 8 plus 1 is 9. Okay, 2 marks each there. So if you get that and don't get the answer, then you'll get 1 out of 2. So that's the value of showing working. If you do that but don't get the answer, you'll get 1 out of 2. Okay, so showing some working here, writing a solution in maths is important. In case you mess up the final answer, you'll get part marks. Okay, let's go down now and have a look at 8. Find the value of this. Well, this is directed numbers stuff, isn't it? A negative times a negative and that sort of thing. And so let's have a look now. Coming across here, we're going to read 15, take neg 9. You're going to reverse the direction and then reverse it again. Remember, a negative in maths implies reverse the direction travelling along the number line. Reverse the direction. So we've reversed it twice. It's going to be back as a positive again, which is 24. Okay, so 1 mark for that one operation. Let's look at this one coming across here. Neg 6 plus 7. I'm going to look at this first. Negative times negative is a positive, so there's 1 mark for that. And then now neg 6 plus 7. We can do these in any order, the addition and subtraction in Bedmass land. So that's 1. Neg 6 plus 7 is 1. Let's just check that. Do you agree? Neg 6 is down here. And we're going to add 7. So we're going to just go past 0 to the value 1. Okay, and then we're going to add 3. So we're going to pop further out on the number line to the number 4. Okay, so 1 for the first line there, and then 1 for that, because there's 2 operations there. Okay, how are you going? Put your marks down. Let's have a look at question 9. Find the last digit of 9 to the 60. Oh yeah? 9 by 9 by 9 by... Oh, no. I can't do that. It's too hard. Okay, you're not meant to do it on the calculator, this particular one. Okay, so how would we do it? Well, let's see if powers of 9 follow any pattern. Let's go 9 by 9. That's 81. Then 81 by 9, which is 9 cubed. So I'll put this here, 9 squared. 9 cubed is 729. And then 9 to the 4th is 729 times 9, which is going to end in a 1. And can you see, as you go on and you multiply that 1, it's going to end in a 9. So it's going to cycle. The last digit is going to cycle between 1 and 9. Okay, so even powers here, you start off with 1, then it's 9, then it's 1. So with that cycling, even powers are going to end up in a 1 every time. Okay, and you've got an even power here, so you're going to deduce from that 9 to the 60 has a last digit of 1 from that pattern that you see there. Okay, so where's our marks for this one? All right, I think I'll just get rid of that. I think we'll give 1 for that, 1 for that, and then 1 somewhere for realising it's going to be between 1 and 9, and then 1 for the answer. Now, there's none for the answer if you've done it on a calculator. You weren't meant to do this one on the calculator. Okay, we're meant to suss it out. Okay, have a go there and see what you got. Okay, here we go. Question 10. Amy has some lollies in a bag which she will share with her friends. She knows she can share them equally whether they're, look at this, 4, 5 or 6 children present. What is the smallest number of lollies Amy could have? Wow, how do you do that? Well, if you're not sure, you could think like this. Hey, this is a number test, and we've been talking about lowest common multiples and highest common factors. Has it got something to do with that? So let's see if we can apply our ideas of those things to this problem. So we have the numbers 4, 5 and 6. And we want those people to get the same amount of, here it is, equally, the same amount of lollies. Okay, so we need what? The same number. So if each of them got 3 lollies each, ooh, how many would we have? 4 times 3 is 12, 3 times 15, 3 times 5 is 15, 18. Oh, we're talking about multiples, aren't we? This would be the number of lollies each person got. So the total number of lollies would have to be the sum of all those. So we want a common multiple, something that is divisible by each of these numbers. What is the lowest common multiple of those 3? Okay, well, let's write them down. 4 is 2 squared, 5 is just 5, voting as a product of primes, and 6 is 2 by 3. So if we want to construct a multiple, we need to have 4 go into it, so it's got to have a 2 squared, it's got to have a 5, because that's a factor of 5, and then we don't need another 2, because we've got a 2 there, into which that 2 would go, and then we've got a 3. So the answer is 60. 60 lollies is what she would need. Get the idea of how you can use maths in everyday stuff, in problem solving, if you can suss out what's really going on. Okay, go back over and think about that. All right, let's do one more of a practical nature. That's question 11, and then we'll want to add up your marks now. Okay, so a passenger train goes through a 2-track level crossing, or there's something important, every 8 minutes. A freight train goes through the same level crossing every 52 minutes. Now they're leading you on here to give you a clue that's got something to do with LCM and HCF. So let's find because here they are, because I tell you to find that. Let's find the factors of 8 and 52 and the LCM of 8 and 52. I'm going to do it slightly differently this time. I'd like to do it a bit more mathematically. So let's go with a factor tree here, 4 by 2, and then we can go 2 by 2. So 8 is 2 cubed, and we're going to then find the factors of 8 and 52, or the lowest common factors, and the LCM. So 52, you want to do it the other way, goes 26, and then 13, and we can't go any further, so 52 is 2 squared by 13. Okay, find the factors of 8 and 52. Well, we found the prime factors there. So we haven't got all of the factors, so we better have a look at the factors of 8 differently. I'm doing this really to get the highest common factor or lowest common multiple. So 8 is going to be what? 1 by 8, 2 by 4, and that's it. Okay, so our factors are 1, 2, 4, and 8, and the 52 is 1 by 52, 2 by 26, 3. Does 3 go into 52? No. Does 4 go into 52? Let's have a look. 4 by 13. There it is there. Okay, so our factors here are 1, 2, 4, 13, 26, and 52. Okay, so we should write them out like that. I was doing it this way over here so that we could look at the highest common factor, which is 2 squared here, and but they wanted the factors. So there they are. Now, what is the LCM, the lowest common multiple? We can construct that by looking at the 2 different numbers. So 8 needs at least a 2 cubed, so it would be a multiple. That's the first multiple. Now that would be enough to cover the 2 squared factor of 52, so that 52 could divide into the number that we're talking about, but we need a 13 as well. Okay, so our lowest common multiple is 8 times 13, which is 104. You might have to do it on a calculator. Okay. All right, so we'll mark that in a minute. Come down, and we've got to somehow answer this question. A passenger train and a freight train go through the level crossing at the same time. How long is it before a passenger train and freight train go through the level crossing together? So that you could think of together as something in common. That's what that word means, shared or in common. So therefore, we want a common time between 8 and 52, or a common multiple. Okay, so it's 104 minutes is the last answer there. Okay, so let's look at marking that and seeing what you get here. We've got 6 marks, so I reckon we'll have 1, 2, 3, 4, and 2 for spotting that was the answer, or the LCM was the answer. Something like that. Okay, add up your marks. I hope you got a few. I hope you enjoyed it also. So come back up to the top now and put your marks here out of 42. Okay, right. I hope you were able to do it in about 42 minutes, because that's another aspect, to know the work well enough to complete it in the given time. All right, so there's your practice test. Good luck. Study this one and study the sorts of problems that you weren't very confident about in this one. Go to the textbook and choose some more problems like that. There's practice examples at the end of the chapter, and just get ready for the actual test. So, and good luck in the actual test. I'll catch you a bit later on. Cheers for now.